I'm baffled, and people were saying, well, what is this?
For years, people dismissed crop circles as pranks and random patterns deliberately pressed into fields overnight. But in 2008, Italian inventor Umberto Baudo argued that certain crop circles encode precise geometric relationships, layouts that can be translated into physical systems designed to generate energy. That claim alone was extreme, but what made it harder to ignore was what he did next.
I think they're made by aliens or extra-dimensionals. I mean, it's a big universe.
He started building those systems in his own workshop, and if those designs actually work, then they wouldn't just be unusual machines. They would represent a form of energy technology that has never been publicly demonstrated, possibly one of the most suppressed ideas in modern history. The first claim. Baudo's idea only makes sense if you understand exactly what he was claiming and why it immediately puts him at odds with established physics. In any mechanical system, energy has to come from somewhere. If you spin a wheel, the energy comes from whatever force you used to start it. As the wheel turns, it loses energy to friction in the bearings, air resistance, and internal stress. That loss is unavoidable. Eventually, the system slows down and stops. This isn't a debated theory, it's one of the most consistently tested principles in science. Baudo's claim challenges that outcome directly. He argued that certain crop circle patterns encode very specific geometric relationships, ratios between circles, distances from a central point, and offset rotational axes. When those relationships are translated into physical components, they create a system where motion doesn't just continue, it increases under the right conditions. The key concept behind his designs is something called an eccentric rotation system. Instead of spinning perfectly around a centered axis, parts of the machine rotate off-center. That imbalance creates shifting forces as the system spins, and those forces can be redirected depending on how the components are arranged. In a typical machine, that imbalance would be a problem. It would cause instability, vibration, and energy loss. Baudo treated it as the solution. By arranging weighted components around an off-center core, based on the exact spacing he extracted from crop circle formations, he claimed the system could recycle part of its own motion. Instead of losing momentum steadily, it would reach a point where the internal forces begin reinforcing the rotation. At that stage, the machine wouldn't need continuous external input to keep spinning at high speed. The initial push gets it moving, but the geometry of the system determines what happens next. That is the part that conflicts with conventional physics. Because if a system maintains or increases motion without additional energy input, then either energy is being drawn from a source that hasn't been accounted for, or the measurements and assumptions behind the system are wrong. Baudo believed it was the first option. He argued that the designs extracted from crop circles were not accidental patterns, but precise configurations that allow mechanical systems to interact with forces we don't fully understand yet. That belief is what pushed him from analyzing patterns on paper to building physical machines in his workshop. Because at some point, the only way to test a claim like that is to stop talking about it and try to make it work. Unmeasured. Most people who study crop circles focus on how they look. They take aerial photos, compare shapes, and argue about whether the patterns are man-made or not. Baudo ignored that entire approach. Instead, he treated each formation like a mechanical diagram that had been scaled up to the size of a field. He started by isolating specific types of formations, ones with multiple concentric rings, repeating circles, and clear off-center placements. These weren't chosen because they looked impressive. They were chosen because they contained structure that could be measured. The first thing he focused on was ratios. He mapped the distance from the center of a formation to each outer circle, then compared those distances to each other. In several cases, the spacing followed consistent numerical relationships. When one circle was placed at a certain distance, the next wasn't random. It matched a proportional increase that repeated across different formations. That's what got his attention. If crop circles were just decorative, there would be no reason for those ratios to stay consistent across different locations and years. But if they were diagrams, those ratios could represent something functional, like gear spacing or rotational timing. From there, he moved to alignment. Some formations weren't centered perfectly. Smaller circles were placed slightly off-axis from the main structure. To most people, that looks like artistic variation. To an engineer, that looks like an eccentric layout, exactly the kind of configuration used to create uneven force during rotation. Baudo documented the offset of each component relative to the center, then translated those offsets into mechanical positions. He wasn't guessing. He was converting measured distances into physical placements. Next came sequencing. Certain formations contained repeating patterns that appeared in a specific order: large circle, smaller circle, gap, then another circle at a precise angle. When he mapped those sequences, they resembled the layout of rotating assemblies where timing between components matters. At that point, he wasn't looking at crop circles anymore. He was looking at instructions. To test that idea, he recreated simplified versions of these patterns using basic materials. Instead of crops, he used magnets and weighted components arranged in the same geometric relationships he had mapped from the fields. These early models weren't meant to generate energy. They were meant to answer one question: do these patterns translate into systems that actually move in a controlled way? When the components were arranged according to the extracted ratios and offsets, the systems rotated more smoothly than random configurations. When he changed the spacing, even slightly, the motion became unstable or inefficient. That result changed the direction of his work completely, because at that point the patterns weren't just visually consistent, they were mechanically sensitive. The exact positioning mattered, which is what you would expect from an engineered system, not a random design. That's when Baudo stopped treating crop circles as something to interpret and started treating them as something to build. And once he made that shift, the next step was obvious. He needed to turn those layouts into full-scale mechanical systems and see what would happen when they were pushed beyond simple rotation tests.
One formation had everyone baffled, and people were saying, well, what is this?
For years, people dismissed crop circles as pranks and random patterns deliberately pressed into fields overnight. But in 2008, Italian inventor Umberto Baudo argued that certain crop circles encode precise geometric relationships, layouts that can be translated into physical systems designed to generate energy. That claim alone was extreme, but what made it harder to ignore was what he did next.
I think they're made by aliens or extra-dimensionals. I mean, it's a big universe.
He started building those systems in his own workshop, and if those designs actually work, then they wouldn't just be unusual machines. They would represent a form of energy technology